my dear students, welcome again. Today we will discuss calculations involving equations, that is stoichiometric calculations. Okay, stoichiometric calculations, that is calculations involving chemical equations. Before going to stoichiometric calculations, we have to know what are chemical equations. We all know that chemical equations are some shorthand representation of chemical reaction. Okay, so we know hydrogen combines with oxygen producing water, is it not? This is a chemical reaction. That chemical reaction may be represented by an equation. What is that? That equation is this one. Hydrogen combines with oxygen producing water. This is a qualitative information regarding the chemical reaction. But this equation is not balanced. To balance this equation, we have to put 2 here and 2 here. This equation is balanced. Because what is a balanced chemical equation? A chemical equation which has equal number of atoms of each kind in both sides of the equation. It is called balanced chemical equation. In this case, there are 4 hydrogen atoms on the left hand side and 4 hydrogen atoms on the right hand side. Similarly, there are 2 oxygen atoms on the left and 2 oxygen atoms on the right. So this equation is balanced. A balanced chemical equation can provide quantitative information also. You see, we can say 2 molecules of hydrogen combines with 1 molecule of oxygen to produce 2 molecules of water. Okay, 2 mole of hydrogen combines with 1 mole of oxygen to produce 2 mole of H2O. Okay, 2 mole of hydrogen means what? 2 times 2 gram, that is 4 gram. 1 mole oxygen means 32 gram. 2 mole oxygen water means 2 times 18 gram, that is 36 gram. In this way, you can say 4 gram hydrogen combines with 32 gram oxygen to produce 36 gram water. Okay. So a balanced chemical equation can provide us useful quantitative information related to a chemical reaction. Okay. Now, this particular number 2, this is called the stoichiometric coefficient with respect to H2. There is 1 here. It is 1 is the stoichiometric coefficient with respect to O2. 2 is the stoichiometric coefficient with respect to H2O. Now, to have some calculations, since we use the stoichiometric coefficients in a balanced chemical equation, such equations are usually called stoichiometric calculations. Okay, stoichiometric calculations. Let us take an example. How many grams of water will be obtained when, say, 30 gram of hydrogen is treated with enough oxygen? We take this example. What is the question? We have to find out the mass of water produced in gram when 30 gram hydrogen is treated with enough oxygen. Here oxygen is enough, oxygen is present in larger amount. So limiting reagent would be hydrogen. Okay, we will take this equation. From this equation we can write 4 gram of hydrogen. 4 gram of hydrogen produces how many grams of water? 36 gram of water. Therefore, 1 gram of hydrogen will produce 36 divided by 4 gram of water. Therefore, 30 gram hydrogen will produce 36 times 40 divided by 4. This much gram of water. This will be the answer. 270 gram of. See, 4 gram hydrogen gives us 36 gram water. This is understood from the balanced chemical equation, because 2 moles of water, hydrogen gives us 2 moles of water. 2 moles of hydrogen means 4 gram of hydrogen. 2 moles of water means 36 gram water. So we'll write 4 gram H2 will produce 36 gram of water. Therefore 1 gram H2 will produce 36 divided by 4 gram H2O. So 30 gram H2 will give us 36 times 30 by 4 gram of H2O. This is 270 gram of H2O. Take another example. Calculate the mass of ammonia obtained by treatment of, say, 300 gram of nitrogen with sufficient hydrogen. Okay, we have to calculate the mass of ammonia which is obtained by treatment of 300 gram of nitrogen with sufficient oxygen. Oxygen is present in sufficient amount, so in this case limiting reagent will be nitrogen. Okay, so let us write the equation first. N2 plus H2 giving NH3. Okay, to balance this equation we have to write a 2 here and a 3 here. See, 1 mole N2 gives us 2 mole NH3. Okay, 1 mole N2 means 28 gram N2 and 2 mole NH3 means 34 gram NH3. So from this equation we will write 28 gram N2. Therefore 1 gram N2 gives 34 divided by 28 gram NH3. Therefore 300 gram N2 gives 34 times 300 divided by 28 gram NH3. The answer is 364.28 gram NH3. So see, we have performed 2 examples in which we calculate mass of, say, product produced with a given mass of reactant. Okay, so in this connection let us define the concept of limiting reagents. Limiting reagent. You see, when in a chemical reaction there is more than one reactant and one of the different reactants is present in a lesser stoichiometric amount, okay, then it is called the limiting reagent. Consider A plus 2B gives C. This is a chemical reaction. From the reaction, what is seen? One atom of A reacts with 2 atoms of B. Okay, so to react with 1 atom of A, we need 2 atoms of B. Okay, suppose we have a reaction mixture like this. Say 100 atoms of A and 50 atoms of B. If you are asked between A and B in this particular situation, which one will be the limiting reagent? We will go to the equation. 1 atom of A needs 2 atoms of B. So 100 atoms of A would need 200 atoms of B, okay, but there is only 50 atoms of B. So in this case, the limiting reagent is B, okay. Here limiting reagent will be B. Consider another situation. Say 50 atoms of A and say 100 atoms of B. Again go to the equation. 1 atom of A needs 2 atoms of B. Is it not? From the equation we can say 50 atoms of A will need 50 times 2, that is 100 atoms of B. In this case, none is limiting reagent. You can consider either A or B both as limiting, because 50 atoms of A would need exactly 100 atoms of B. So in this case, none of A or B would remain unreacted. Okay. So here you can say both are limiting reagent or none is limiting reagent. In this particular case, B is limiting reagent, so A would be left unreacted. In this case, A is left unreacted. Okay, but in this case, since 50 atoms of A would need 100 atoms of B, so simultaneously A and B both will be used up, both will be finished. So in this case, no reagent would be left unreacted. No reactant or reagent would be left unreacted. So none of these two is limiting or both of these two are limiting. Okay. Come to situation C. 100 atoms of A and say 500 atoms of B. Okay. Situation 3. Again go to the equation. 1 atom of A needs 2 atoms of B. Okay. So 100 atoms of A will need 200 atoms of B. But there are 500 atoms. Okay. What does it mean? It means there is excess of B in the reaction mixture. So which one is in lesser stoichiometric amount? A is in lesser stoichiometric amount. Okay. So in this case, A is limiting reagent. Limiting reagent is what? A. Then which one will be left unreacted? B would be left unreacted. B would be left unreacted. Okay. So in this way, if you consider number of atom or number of molecule of reactant, then it can be easily understood the concept of limiting reagent. Okay. Take another reaction. Say H2 plus Cl2 gives 2HCl. Okay. This is the chemical equation representing the formation of HCl from hydrogen and chlorine. Here we will say 1 molecule of H2 react with 1 molecule of Cl2, or 1 mole of H2 reacts with 1 mole of Cl2. Okay, 1 mole H2 means 2 gram, 1 mole Cl2 means 71 gram. Suppose we have a reaction mixture, say 10 gram of H2 and suppose 50 gram of Cl2. Okay, we have a reaction mixture of 10 gram hydrogen and 50 gram chlorine. Go to the equation. 2 gram hydrogen needs 71 gram chlorine. Okay, 2 gram hydrogen needs 71 gram Cl2. So 10 gram hydrogen would need 71 by 10, by 2 multiplied by 10. This much gram Cl2. Okay. So 71 multiplied by 5, 35. So to react with 10 gram hydrogen, we would need 355 gram of chlorine. 355 gram of chlorine. But there is only 50 gram chlorine. To react with 10 gram of hydrogen, according to the equation, we would need 355 gram chlorine. But there is only 50 gram chlorine in the reaction mixer. So chlorine would be the limiting reagent. Okay. Here, limiting reagent is chlorine. Hydrogen will be left unreacted. Okay. There will be some hydrogen left unreacted. Suppose 25 gram hydrogen plus 2.5 kg of chlorine. 25 gram hydrogen is treated with 2.5 kg of chlorine. 2.5 kg means 2500 gram. Again, you go to same procedure. According to this equation, 2 gram hydrogen needs 71 gram chlorine. So 25 gram hydrogen will need 71 by 2 multiplied by 25 gram chlorine. This would be 887.5 gram. 887.5 gram. So actually we need this much gram of chlorine, but there is excess of chlorine because it is 2500 gram. We need only 887.5 gram. So in this case, limiting reagent will be hydrogen. Limiting reagent will be hydrogen. Okay. So I think you have understood the concept of limiting reagent. What is limiting reagent? If in a reaction we have more than one reagent, and one of the different reagents is present in lesser stoichiometric amount, then that reagent will determine the amount of product obtained, and it is called limiting reagent. The limiting reagent would be used up completely in the reaction, but the other reagents would be left unreacted. Okay, the limiting reagent would be used up completely, the other reagents would be left unreacted. Okay. Now whatever calculation we have done, we have already done 2 calculations, and those 2 calculations relate mass of one substance with mass of another substance. Such type of calculation, which is done by using the relationship between mass of 2 substances involved in an equation, it is called mass-mass relationship. Similarly, you can make some other type of relationship, say mass-volume relationship. Okay? Let us do a problem of mass-volume relationship. Say C, solid, plus O2, gas, producing CO2 gas. Look at the equation. 1 mole carbon reacts with 1 mole oxygen to produce 1 mole carbon dioxide. Suppose you are asked a question like this. Say what volume of oxygen at NTP would be required to react completely with 1.2 kg, 1.2 kilogram of carbon. 1.2 kilogram of carbon. This is a problem that relates mass of one reactant, carbon, with volume of another reactant, oxygen. Okay, so clearly this is a problem of mass volume relationship. From this equation, see 1 mole carbon means 12 gram. Okay, again 1 mole oxygen means 22.4 liter at NTP, because this is the molar volume of any gas at NTP. Molar volume of any gas at NTP. So from this equation, what can we write? We can write 12 gram carbon needs 22.4 liter O2 at NTP. 12 gram carbon needs 22.4 liter oxygen at NTP. Therefore, how many grams? 1.2 kg means 1200 gram. This much carbon needs 22.4 divided by 12 multiplied by 1200 liter oxygen at NTP. Okay. So 2240 liter of oxygen at NTP. This is the answer. 2240 liter of oxygen would be required to burn completely 1200 gram of carbon. This is a problem of mass volume relationship. Consider another example. Say, calculate the volume of CO2 produced by heating 1 kg of limestone with 90% purity. Calculate the volume of carbon dioxide produced by heating 1 kg of limestone with 90% purity. In this case, we will need this equation. Limestone means calcium carbonate. This is a solid substance. When it is heated strongly, we will have calcium oxide solid plus carbon dioxide gas. Okay. We are to relate mass of calcium carbonate, that is limestone, with volume of carbon dioxide. So write 1 mole here, 1 mole here. 1 mole calcium carbonate means its molar mass. Molar mass means 40 plus 12 plus 48, it is 100 gram. 40 plus 12 plus 48, okay, 100 gram. 1 mole carbon dioxide means 22.4 liter at NTP. Okay. So 100 gram limestone calcium carbonate produces 22.4 liter of CO2 gas according to the equation. Now what is the mass of limestone given? The mass of limestone given is 1 kg, but that mass of limestone is only with 90% purity. So right here, mass of pure limestone equal to 1 kg means 1000 gram multiplied by 90%, that is 90 by 100. So this is 900 gram. Okay. From this equation, we will now write 100 gram of calcium carbonate, that is limestone, produces 22.4 liter of carbon dioxide gas at NTP. Therefore, 900 gram of calcium carbonate will produce 22.4 divided by 100 multiplied by 900 liter of carbon dioxide gas at NTP. So 22.4 multiplied by 9. 22.4 multiplied by 9. This is 201.6 liter of carbon dioxide gas at NTP. This is the answer. Okay. So we can relate mass of one reactant with another reactant or product. Similarly, mass of a reactant can be related to volume of product or volume of another reactant. So we have mass or mass volume relationship. Similarly, we can have volume relationships also. Okay, volume relationship. Let us have a problem. Calculate the volume of oxygen needed to burn 5.6 liter of methane completely. Okay. So we make the equation: methane plus oxygen gives you carbon dioxide plus H2O. See, 1 mole methane needs 2 mole oxygen. 1 mole methane means 22.4 liter. 2 moles means 2 times 22.4 liter, that is 44.8 liter. So at NTP 22.4 liter of methane needs 44.8 liter of oxygen. Therefore, 1 liter of methane needs 34.8 divided by 22.4 liter of oxygen. This is 2 liter of oxygen. Okay. Therefore, 5.6 liter of methane will need 2 times 5.6 liter of oxygen. Okay. That is 11.2 liter of oxygen. This is the answer. In this way, we have mass relationship, mass volume relationship, and volume relationship, which could be done by using a chemical equation. You have to check whether the equation is balanced or not, because only a balanced equation can be used for the calculation. And this type of calculation uses the stoichiometric coefficients with respect to particular reactant or product. Okay, so it is called stoichiometric calculations. Okay, thank you for attending the class. In our next class, we will go to calculations involving solutions. Okay, thank you.